Hello, welcome to another online exclusive for PDC 2008. My name is Kevin Hill. I'm a program manager at Microsoft, and today I get to talk to you about driving for software quality through customer feedback. This is kind of a gist of what we're going to go over today. Your customers are feeling pain in the ecosystem. Are you listening to them? This presentation is going to help you learn about the Windows Error Reporting Platform, how you can gain access to the data provided by this platform, about the developer portal site we've built that you can use, and also about our new service interface that we've recently released and you're able to take advantage of. I'm going to start by looking at the Windows ecosystem as a whole and kind of give you some context for where users fit into all of this. We have a lot of partners at Microsoft, and the first place where users get a taste of some of the Windows software is through OEM images that exist. We have the opportunity there for OEMs to customize images, do add-ons, place additional software on the machine for the users. Sometimes this can cause issues within the ecosystem if it's just released and isn't fully tested with everything. Another area is the software itself that shows up on the machine. We have a lot of partners that will pre-install multiple different applications for users out of the box. One example is having multiple antivirus software on a user's PC. A lot of times this software doesn't interact very well together and can cause an unpleasant experience for users. Then next, of course, we have the hardware devices, webcams or printers and keyboards and mice. And we need to make sure the right drivers are on the machine in order for the user to have a pleasant experience with that. And then also we have great retail partners out there, and some of our partners that exist out there, they want to do some value-added services for users. We've seen out in the ecosystem where some partners have wanted to increase the performance of users' computers. And so they've actually gone out and configured some settings and whatnot to try and improve the performance and the experience for the user. And we've seen where, in fact, there's been procedures followed where it's actually slowed down some performance, where they've flipped some setting to slow down disk I/O instead of increasing disk I/O like they thought that it would have. So in the middle of this complex ecosystem with all these different partners contributing, we have the user. And they're out there using their PC every day. They can experience crashes and hangs, slow and unresponsive software. And then, of course, there's malware out there that can also contribute to this ecosystem. So with this huge, complex ecosystem, it's hard for any one partner to understand how what they've done to try and provide a better experience for the user could actually have an adverse effect down the road. The Windows Error Reporting Platform as a whole is actually an easy way to get a view into this ecosystem. So the Windows Error Reporting Platform monitors unhandled exceptions that occur. So as the user's experiencing these, we can capture unhandled exceptions, report that back to Microsoft, and share that out. Just to give you kind of some insight with partners we've worked with in the past, we've had partners that when we originally launched with Vista made up with a near 10% crash rate on Vista, meaning they were 10% of all the crashes on Vista. After working with our data and tapping into this data stream and downloading memory dumps and debugging, they actually reduced very quickly down to just a couple of percent, and then now they're just not even significant percentage of crashes that exist out there today. So by taking advantage of this, we've seen a lot of successes out there with various partners in actually reducing crashes and creating a more pleasant experience for users. Let me take a step back and talk about the history of Windows Error Reporting. It's somewhat interesting to me. It was born in Microsoft Office, and at the time it was called Dr. Watson, and it was a tool that was built internally here at Microsoft by the Office team to monitor crashes and help automate the reporting of those crashes, gathering of the crashes so that it could be shared with the developer to debug them. And then later, we saw huge value in this. In Windows XP SP2, we included Windows Error Reporting as part of the OS. It shipped with XP2. And this is when, of course, we've all seen the send error dialog pop up, send error dialog to Microsoft. Then even when Vista launched, we went another step farther, and we included it in the core OS. So there's actually a Windows Error Reporting API that's exposed through the Core OS and Windows Vista, and we're continuing to make improvements forward with Windows 7 by adding on to the API and providing more functionality. What does it cost? Everyone wants to know. There's no licensing fee. The great thing about this service is essentially free. The only cost we have is when you initially sign up is the cost of a Class 3 VeriSign cert to sign a piece of code. What do you get out of it? Well, you get amazing benefits out of this as a partner of Microsoft. When you're doing development on pre-release software, you can cut costs on support. You're going to find bugs earlier. You're going to be able to fix them before it releases out into the ecosystem. And it's just a wonderful story. But then after it's gone into the ecosystem, the post-release, now your customers are using your software. What's happening there? Customers are great at finding scenarios that we weren't able to test against, so we're still able to monitor unhandled exceptions, capture that information, bring it back and share it again. So the last value add that we have with this platform is that we give you a quick way to respond to your customers. So I'm going to go into more detail through what you can do with the platform in my next slides. So if you look at the ecosystem from a crash perspective, we've seen very clear trends in error reporting data. So the top 1% of all unique signatures actually composes 50% of all crashes out there. And if you look at the top 20%, you see that that covers 80% of all crashes out there. We kind of have this good 80-20 rule. So you fix 20% actually here, you get 80% benefit. It's this nice Pareto curve that we've seen in analyzing the data over many years. So the window error reporting process, it all starts with the customer's machine. Once your application is released out there, a crash can occur. If it's an unhandled exception, we'll capture that. The Windows Error Reporting Client, the WIR-client.exe, will capture that crash data, capture that memory dump, and then it's going to collect this data. And this is where I like to point out there's actually two different sides. We have a software user mode side, which is what I'm talking about here today, and there's also a kernel mode hardware crash side, so the blue screen. It behaves a little bit differently for each as far as when it sends the data or tries to send the data back to Microsoft. By default, the first data that's collected is just a handful of parameters that we look at that's non-PII information. There's no memory crash dump. It communicates these parameters back to Microsoft servers. We take a look at the signature. We see if we've seen this before. If we have and we want to get additional data, we can send a message back to the work client that's going to say, could you try and grab a memory dump? We don't have one. We want to share this with a partner, and we grab that then. For the software side, right when the exception happens is when we try and do the interaction. For the hardware side, we actually wait until it reboots after the blue screen of death, then the machine reboots, and the computer will then ask if users, if they want to send additional information to Microsoft. So then Microsoft will share this data with partners who, the key there is to come register on our portal and sign up and map your software binaries, and then we can match the signature of these crashes against your mappings and then start sharing some of the data. And once we share the data, the hope is you're going to actually troubleshoot some of these crash dumps and try and find a fix for a problem that's been identified out there through the platform. And then you have the benefit also of responding directly to customers that have experienced this crash. So that's the full loop of our Windows Error Reporting process. It's pretty straightforward and pretty simple. So I'm going to talk a little bit now about the experience the user goes through. So this is the first step of the process when a crash happens. On Windows XP, they would see the Send Error Report button. On Vista, they have a very similar dialog. After looking at the data over many years, roughly we found an estimated 20% of users will click the Send Error Report to Microsoft from a Windows XP client. And since we've actually modified how users can opt into the program with Windows Vista, we anticipate there's a much higher percentage. It's about 80% of people who have opted in, back to the nice 80-20 rule. The experience with Vista is when you first install the machine and you run through the setup, if you choose just the recommended settings, you opted in just to send the non-PII parameters over to Microsoft so we can look at the crash signatures and then see if we need to request additional information from users. So on a Vista machine, if your application is developed for Vista or even Windows 7 moving forward, you're going to have a much higher rate of users actually sending back information. So these parameters I've been mentioning, we often refer to them as a bucket. Well, what is a bucket? It's essentially composed of 6 different parameters: application name, application version, module name, module version, the code offset where the error occurred, and the exception code that's thrown by the OS. I've taken a screenshot of one that you can see in Vista. I actually noticed on my slide the module name is empty, but if you look over in the screenshot, you can see where the module name is populated. There's some additional information we capture, like the LCID, the OS version. We don't use those parameters as part of the bucket to count it as a unique signature. That's just additional information we collect, and when I walk through some slides of the portal, I'm actually going to show you how we display that information as well. The crash types we support currently, we have 32-bit crashes, 64-bit crashes, special exceptions, which are going to be data execution prevention or buffer overrun. Usually security-related issues would fall into a special exception. The Vista hung events, so when an application hangs in Vista briefly, we capture those events. Windows Mobile, if you're developing on Windows Mobile, we're able to get Windows Mobile reports as well. Manage CLR code, and then also we have the ability to work with partners to define custom types. Anything outside of this range, we can work one-on-one to try and define. So I've told you what a bucket is. I've told you how it's sent in. How do you get access to it? So I'm getting ready to go into my first of 4 demos here, and I'm going to show you how you can actually map your software. And it's very simple. You're going to download a tool from Microsoft Download Center. You can create a mapping XML file, and then you're going to upload it to the WinQual site. So let me go ahead and go to my desktop, and I'm going to pull up the Microsoft Product Feedback Mapping tool. As you can see on my screen here, I'm going to create a new mapping file. As I go through, I just need to browse to the directory where I have my binaries. I just made a quick little sample app. There's not too much here. I just choose my directory, hit OK. I'm going to give it a product name and a product version. So after I fill those in, hit next, and it's giving me a warning saying, hey, some of these files we couldn't map. We'll tell you why. If I read through it, it says, hey, we know this is a Microsoft DLL, and it's not going to let me map it. That's a good thing. Then it gives me the list of the 2 exe files that I wanted to map on the site. I could choose to exclude or include. This is an opportunity where I could focus maybe on the binaries I care about most to see crashes for. So I go ahead and hit next. I'm going to actually just save it locally. It's going to probably tell me to overwrite the last time I did the demo. And then we have a handy little checkbox at the end that actually drives you to our site. So if I've already logged into the site, so it should take me right to the page if it's behaving well. And then I can just click a button and manually upload this XML file. Here we are at the file upload page on the site. If I click Browse, there's my one of my 2 demo files I've made. I could submit that to the site. It's going to upload this mapping information. We look at the binary name. Let me navigate to the mapping page here so I can show you really quickly that it did upload. So I've got a couple different incarnations through my demos, but if I go ahead and pull up this one, you'll see it has the file name, file version, the link date, so the date it was built, the date I uploaded mappings, and the account I used to upload the mappings to the site. And actually, after you've uploaded it from here, if you wanted to, you could still remove any files that you didn't want to see binaries for. So that was a simple, quick, and painless demo. Let me jump back into my slide deck here. My demo slide. So I talked about the stuff that we collect from users, and what we do is we store all these files in a cab file, and essentially it's like a zip file. And by default, we try and grab a mini dump, a mini memory dump from the user's session when this occurred. We're also able to get heap information, but it doesn't come by default. By default, we just try and grab the mini dump. You're able to go to our site, and actually, I'll show that when I walk through some of the site screenshots where you can actually request a heap dump for specific crashes. Some additional information that comes in these cab files, we have a wickle.txt file. And basically, any WMI query that can be run, just read-only, nothing to do with execution, but any WMI query can be run, and the results are then stored in this file. So a lot of times it's just, hey, give me the list of applications that were running on this machine or installed on this machine, and so it can be customized information. We also provide a version.txt file, which is essentially OS version information, and can also include some additional information in there. There's also an appcompat.txt file, and this is a list of binaries that were in the same directory or any subdirectories of the executable that crashed. So it doesn't have to do necessarily with what's loaded in memory, but we can say here's all the DLLs that existed for this executable. Here's other executables that were loaded in that same directory as the install. So this is actually where I'm going to go into a few screenshots of the portal and walk you through just some generic information you can get. When you first come to WinQual, you're going to see a page that looks like this. We're a small part of the WinQual portal because there's also the logo program. There's some test signing, and there's also some device driver information as well. We live under the Windows Error Reporting section, and specifically the software submenu and the software homepage brings you to the ISV developer portal site. I've taken some screenshots of just one of our sample companies we call Spiral Orbit on the site. As you come to the homepage for the developer portal, you're going to see there's a few extra items listed in the menu, and you might have seen them in my earlier demo, where you can manage your mappings, manage responses, look at product rollups, and get some mobile information as well. If you look at the homepage on our site, you're going to see three key sections, and the first one at the top is the security alert. So I talked about earlier the special exceptions. This is where we store any events that had to do with data execution prevention and buffer overruns. And you can dig up more information on that outside of this discussion, but we classify those there. So if you clicked on that, you would get a list of buckets or crash events that actually were just related to those two items. We also have another section called escalations. So if you remember when I was describing the parameters of a bucket, it had application name, application version, module name, module version. Well, this is a way that we try and bucketize unique crashes and signatures to produce that hit count, and that's what we use for the data analysis on that chart I showed earlier. But we have a team who internally tries to run across multiple buckets to find out if there's a single problem that could be focused on by a partner, and by fixing that single problem would actually resolve multiple buckets. And so anytime we find one of these issues that is more bang for the buck, we add it to this MS escalation. We internally at Microsoft open up a bug item on it to track. Oops, let me go back. And ask that you would contact us. We give you the name of the file, the version. If you click on that link, you can actually have a dialogue back and forth with our internal resources that are helping resolve it. And then probably the most popular thing we have on the site is the company hot lists. And this shows you a list of events organized by hit count. So you can see the total number of hits on the right-hand side, the average hits per day, the type of crash. The response column shows if there's a customer response filed for this. The cabs icon shows if you can actually download cabs, and then this is the bucket ID that you would see within the system as well. And so from this page directly, if you wanted to get your hands dirty, you could actually click on the cabs icon. It would pop up this window, and you could download a cab and load it into a debugger. And I've got some demos where I'll actually show how this works with our service layer. So the additional information we gather, I talked a bit before. I said, well, we gather LSID information, OS information. Well, we give you a breakdown of this. We say, look, this particular issue right now, 69% of the time is happening on Windows XP. And the language breakout, we provide percentages. I apologize, it was cut off in my screenshot, but it's ordered by the highest percentage first. And the LSID information is just what language version of the OS was installed. It doesn't really talk too much about the geography of where this happened. But what it's helped some of our partners do is figure out if there's a localization problem in software. When they see one language just taking off that was unexpected, typically that means there's some issue with the localization that's causing users more grief. So I had talked about being able to collect additional information beyond just the default information I covered in the previous slide. You can ask for processor and memory information to be included, display information to be included, codec information, and then also collecting a heap dump. And that's probably one of our most popular. There's also a way for you to request additional files for the work client.exe to try and gather and put in the cab. And right now we just list some common environmental variables. If you're storing log files there, you could add that log file to the list, and then we would try and include that in the cab file and deliver it when you download it. So I talked a bit about the next demo. We've released a service layer that allows for, let me get through my slide here, sorry. So we released a service layer that allows developers and partners to actually access most of the data on our site going through web services versus having to drive directly to the website itself. This is a project that we've hosted on CodePlex. We released the source code to it. It's the first step we see in actually trying to enable a better platform for partners to get this information and automate it into their systems. Internally at Microsoft, we actually take this crash information and we run it through a program that does extra analysis on the cabs, matches it against our private symbols, finds more specific information about where the problem was, and then automatically opens a bug and assigns it to a dev team here. So we use this for a lot of our major product releases, a lot of our internal product groups sign on to use this technology and get automated bugs open for them. So this gadget is just kind of a preview of how you can automate some of the data from our system into your environment. And of course, you're going to want to go to codeplex.com. I've included a link at the end of this deck that you can go and check out our CodePlex projects and efforts, and I'll talk a little bit more about that later. Install the gadget on Vista, or it also works on Win 7. Add some events you want to watch to this gadget, and then you can directly download cabs to the gadget without having to visit the site. So let me jump out of my presentation once again. So you can see I have the gadget already loaded over on this side. Let me go ahead and navigate to my software homepage. I'm going to pull up the information about some of our hits. As you can see here, I've downloaded a couple of cabs files, but this is the same interface you would have had on the site. It's just available to you locally here. I might have gotten a timeout message. Let me quickly try and log back in if it'll let me. But I'll continue forward with this demo. So, here we go. It caught up with me. So I can come to my site here and say, you know what, this is an interesting bucket to watch, or maybe I want to pick a bucket from over here. Let's actually do something fun and find a special exception type. I can actually click and drag that over to my gadget. I have to make sure that I specify the actual event type. It defaults to Crash 32, our most common. If I click Add, it's going to think for a little while. It's actually going back to our site right now, trying to use the web service layer to pull in information, and then we'll see shortly here it'll populate the information it knows right down here, special exception. If I click on that, you can see that I've got 10 cab files I could download. I'm going to go ahead and click download for one of those. Now it's calling back into Microsoft corporate domain. It's asking for this cab file. Once it finds it, it's going to now copy it out to the partner's domain so it could be downloaded. So it's just saying wait. As soon as it downloads it, I could have clicked on a rather large cab and it's just waiting to copy it. It'll pop open a window and we'll actually see some of the cab files associated with this, or we'll see the files in the cab associated with this. So I'm actually, in case I did click on a heavy one, I actually downloaded a couple examples, and here you can see this was Internet Explorer crash, and these are the typical files that would appear in the cab. The app pat text I talked about, the version. This actually has a heap dump and a mini dump both included in the file. So there we go. The gadget finally downloaded and pulled. This has a heap dump and a mini dump as well, version and app compat text. So that was great. Let me jump back in to our current presentation. And then I completed the demo. So there's a place you can go to actually download some debugger tools if you're not familiar with it. Microsoft.com, WHDC site, /dev-tools, the links here. And we have common debugger tools, WinDGB, the log viewer and the CDB tools are all there. And then I'm going to actually do another quick demo because we all love our demos to show you this cab file I had just downloaded, or one of the cab files I had downloaded. I'm going to open up Windows Debugger, and I'm going to go ahead and throw this dump file into the Windows Debugger. Open it up. Now I am going to ask for some information to say, hey, what was on the stack? It gives me a little bit of information that was on the stack. That's interesting and cool, but I think what might actually be a little bit more interesting is if I go out and I point this to the Microsoft public symbols and see if we can't get some more information. So I'm just copying and pasting in the location to the symbols. I have to adjust the path for this demo machine. I set it up on the C drive. I'm going to go ahead and point it there. It says, hey, the symbol path is just updated. That's great. Now I'm going to do a reload command, and it's going to reload the symbols. So now if I do the same command, you see that I get a lot more enriched information because it was matching up against public symbols. So I know where to actually go and look. And that's the full circle to get the cab and then start the debug process. It's fun. So let's go back into our deck. And this is one of the most important pieces of the platform that we deliver today. So there's all this hard work that goes into developing an application, debugging, and providing a fix. But now you can actually respond back to the users that experience this. So I actually put up here just a typical response for a Microsoft KB article. I've highlighted on the screen, there's actually the version number of the OS. So on a response, you're able to target OS version numbers and actually language, and we actually have some other branching logic that's available as well. Those are the most common used. So you can provide a different response for a user that crashed on XP versus a user that crashed on Vista. You might have different steps, different information that will help them. So these responses are great. You can get information to a customer fairly quickly. So from the time you actually come back to our WinQual site, submit a response, it could actually be out in the ecosystem within a couple of days. Sometimes it can be a little bit faster than that. Typically, it's about a 24-hour turnaround for just generic responses. We've done a lot of analysis on the response data. We've read a lot of customer comments that have come back, and we found it's very simple to actually make a good response for a customer. The good responses are responses that have a link that directly downloads a fix that the client's going to run, install, and update a piece of their software. Those get the highest satisfaction ratings from customers because customers are able to provide feedback. My next demo is actually going to show a sample application crashing and a response popping up. So I think I get to go and do that right now. Let's jump into that demo. So I have an application loaded here that actually is going to cause an Internet Explorer crash. And so if I go ahead and I create my crash, you can see that my application stopped working. In a lot of demos, that's a bad thing. In mine, it's a really good thing. If I hit close program, now this is the experience a user would have in Windows Vista. The response pops up. I can read it and see if it has useful information. There's a particular one saying, you know what, you'll find what you need if you go to Windows Update. Great. I can say, was this information helpful? I have the ability to say yes, no, somewhat. If I click on any options, then I can actually provide additional information to say what was good about it, what was bad about it, what we might like to fix. By reading these comments that users have provided, that's how we determine, you know what, users are generally happy when it's just a one click to a solution. And so that's the demo I have for responses. And I want you to know at PDC there's a lot of wonderful content that Windows team's putting out there. And here's some other sessions that are related that you'd be very interested in checking out. The Using Instrumentation and Diagnostics to Deliver High Quality Software is going to be a great session. You're going to want to be there or watch it on the web. Developing compatible applications for Windows, another great session telling you how to keep your stuff going for future versions. Hands-on analysis with Windows Performance Toolkit, an amazing session you'll want to see. And then best practices for signing and verifying code on Windows 7. All great content, very exciting content for you to watch. What's the call to action? What are we asking for you to do? Very simple. We want you to go register at winqual.microsoft.com. Did I mention earlier it's free? There's no reason not to use this. This is great stuff. Then you just need to map your binaries. You can then respond to your customers. And the last call to action I have personally for you is to become active with our CodePlex efforts. The service layer that I demoed for you is in its infancy. It's just its first step. We want to be able to provide data in a way that you can integrate it within your own system and get some of the same benefits that Microsoft enjoys by itself by hooking up these cabs automatically to symbols, producing bugs, assigning them to dev teams, and getting issues resolved and fixed quickly. So if you become an active member of the CodePlex project, we get better, quicker feedback from our partners, and we know where to focus our efforts moving forward. Here's some resources. I've included some URLs to all of the things you've seen here in my deck today, and also an important one at the end is how to contact my team directly. It's we're@microsoft.com. That's WER at Microsoft.com, the acronym for Windows Error Reporting. And if you have any questions about getting signed up, using our services, or want to learn more, that's a good place to start. So thank you for your time today. I hope you enjoy the rest of the sessions at PDC and get cracking on cabs.